Hello and welcome everyone. Thank you for joining us today. The topic of our webinar is prompt engineering, and it's going to be presented by myself, Shane Johnson. I'm responsible for product marketing here at Snorkel, although my background prior to making the move was in Java and distributed systems. So I'm very excited to have opportunities to talk AI with folks. And I'm also joined today by one of our great product managers, Grace. Grace, you want to say hi to everyone?
Yeah, hi folks. As Shane mentioned, my name is Grace. I'm one of our senior product managers here at Snorkel. My background is actually in product management in the generative AI space. And then before that, I was doing physics research. And we're both excited to be here with you guys today.
Awesome. I'll be honest, I did not know about the physics part, so that's pretty
We'll
fascinating.
talk later.
Yes, definitely. All right, let's dive in here. In terms of the agenda, I have a few slides on introduction, so bear with me. I understand some folks might be relatively new to prompt engineering, and we also have some folks who are already pretty well versed in hoping to find something new. So I have a light introduction. We'll talk about a handful of model parameters. Not necessarily all of them, but at least some of the influential ones. The general structure and components of a prompt, right, or a prompt template. A handful of, I'd say, common or standard best practices. And then the part that represents a fair amount of the meat here, if you will, and hopefully you can find some takeaways from this, is I picked 9 prompt engineering techniques to discuss. Some of these are fairly common, chain of thought. Others I grabbed because I thought they were pretty interesting or fascinating to me. And then some, which I want to call new, but in our space, new may only last a week or two. So maybe I should say recent techniques. So hopefully there's something in there that's new and informative to you. And then I'm going to turn it over to Grace, who's going to talk a little more specifically about our approach to it at Snorkel and how we're bringing that into our product. And we'll see a live demo, or sorry, a demo of that as well. So in terms of the introduction, you know, one perspective I wanted to share with everyone is that, given our background in data and AI, we can think of LLMs as functions, right? Very simple functions. You pass in a prompt and you get a response, right? And generally, the idea is that, the better crafted, specific, detailed, the input, the better the response, right? Or accuracy, higher quality, so that there's certainly that notion of prompt engineering as a means to get better responses from the LLM. But what I also wanted to tease out is that I think of prompts, or maybe more specifically prompt templates as functions too, right? It's just that we're writing a function in natural language as opposed to code. And I say that because, the way I think about it is I want these prompts, or functions to return predictable results, but just as if you were writing code, right, and you're creating functions and methods, you want a certain degree of abstraction, right, so you can handle a larger variety of inputs and scenarios. Certainly, prompt engineering isn't an activity that you would scale, in the sense that you create a crafted prompt for every possible request. So you need some degree of abstraction, but we also need confidence and predictability. So yes, we're going to talk about how can we structure these inputs so as to induce the desired response or correctness. But also when I get into the techniques, we'll talk about how we're trying to incorporate a little bit of abstraction as well. And there was one more element that I thought was worth touching on is, I can't speak for everyone, but for myself, I instinctively think is prompt engineering as a practice for improving production Gen AI apps, right? If you're building AI co-pilots or AI assistants, we're going to want to incorporate some degree of prompt engineering to make sure that the users are getting, great answers back. But there's two other areas, and we may touch on this when we get into the techniques, that prompt engineering is equally as important, maybe in some cases more important. The first one was synthetic data generation. So more and more, we can use LLMs to help us generate training data, right? We might pass them a PDF document and ask for, one or more questions that could be answered by the contents of that document. We might also then kind of go back and, combine our original prompt, with context and then get the answer to those questions. And then evaluation, same thing when we start looking at LLMs as judges, on whether our responses are accurate, complete, fair, utilizing the context appropriately, and so on. Again, kind of I boil it down to a simple function, right? If I pass this prompt, context, and response, I'm expecting to get a Boolean back, whether it's accepted or not. Simplifying it, of course. So keep in mind, when we think about prompt engineering, it's kind of across the spectrum, and that there's lots of places where it can be helpful to you. I wanted to start with model parameters. These are probably your first area where you might make some changes in terms of kind of trying to get the right response back. And I kind of picked 3 to discover here. One is the temperature. We could think about it as randomness. So essentially what's happening is kind of towards the end of this process, we have a probability distribution of what the next token could be, right? There might be 50 tokens. Some of them have a very high probability. Some of them have a very low probability. And generally, the LLM is going to pick, the token with the highest probability. But if you modify the temperature, you can start to influence that. So maybe it's not always picking the most probable tokens, right? Occasionally it's picking in, less probable tokens. The way I've always thought about it was kind of creativity versus predictability. But I put a link in here because I found an interesting research paper, and they were, propositioning that it's not so much creativity, but novelty. Whether you want very novel responses or very predictable responses. So I'll leave it up to you to decide, how you interpret that. But, if we turn the temperature up, we're going to see, a bigger variety of responses. If we turn the temperature down, given the same question, we're going to see very consistent, predictable responses to that question. And then you have top K and top P. So top K, look at it as we have this probability distribution. We'll sort it from the highest to the lowest, and then you set an arbitrary number on kind of the top end that you want to get. I believe the default is 50 for most models that are available, but you might only want the top 10 or top 20 top K. Top P, a little more interesting. You might have heard it referred to it as nucleus sampling. The idea is we still have, the next token probability sorted from high to low, but rather than picking a count, we're picking what, I think you might see it referred to as a probability mass, but you might say, 80%. So add up, these next tokens until their cumulative probability hits that 80%. So there's some variability there in terms of what the distribution looks like and how long it'll take you to reach that probability mass. So 3 different approaches here. And I added this diagram, which I found in a blog, which I really, really love, because as much as I like to go into it, it's kind of true, right? There's a whole bunch of math going on throughout all these layers. And then you get a whole bunch of numbers, which are generally vectors. But what I did want to use this is to explain that the temperature is applied before the probability distribution. So that temperature setting I was just talking about, that's really modifying the logits to result in, say, an accentuated distribution, right? The most probable will become even more probable, the least probable even less, or vice versa, depending on the setting. You get your probability distribution, that's when your top K or top P are applied. So you can use all 3 together, you can use a combination of these. In the strictest sense, if you want very predictable responses, you could do any one of these, right? You could have, extremely low temperature, top K equals 1. They'll kind of accomplish the same thing. Where it gets more interesting is when you're in the middle, and try to experiment and find, what's the right response look like to you. In terms of prompt elements, I think this is fairly straightforward. Usually begins with assigning the agent a role, providing some instructions, likely some examples. In terms of RAG, we have our context inserted, the question, right? Kind of the user prompt, if you will, and maybe some indication of what you want back, right? Should it be in Markdown? Should it be in text? Should it be in JSON? There's no one fixed structure. There's lots of different variations of this, but I think it's worth thinking about your prompts in this way, right? At least trying to structure them in your head, if not physically. Some standard best practices here. I understand these will probably be more self-explanatory, but just as if we were conversing with, another person, being very specific, being very detailed. I happen to be very much an example-based learner. So if you put 2 or 3 examples in front of me, that will be far more effective than 1, 2, or 5 page, summary or documentation. And then kind of one thing that applies so broadly in the AI space, from training data to evaluation to even here, in terms of prompt engineering, is yes, we do want to describe not just what it shouldn't do, but what it should do. Try to keep both those things in mind, right? There's this notion of telling it what you want. There's a notion of telling it what you don't want, right? There's value in both, but be very clear what it is that you do want. So again, pretty self-explanatory. Use punctuation, please, in all things. So I'm going to pivot to prompting techniques. As I said, we have 9 of them. I'll try to go through these fairly quickly, so I'll make sure we have time to see the demo and for Grace to kind of walk us through, our approach to it. So given that, I'm not going to be able to do these justice, right? These are pretty great research papers. I'm going to try to give you an introduction, though, or at least a high level interpretation of these. The first one, few shot, probably the most common, right? Quite simply, we want to provide the LLM with examples, right? And they could be very concise. They could be, very detailed. Some things that I think are good to remember, though, is that you do want, consistency and diversity. So in one sense, on the right there, this is taken from the paper, all these images are. You can see the consistency in the examples, right? They all kind of have the same structure, but you also want some diversity. If possible, have good and bad examples, right? Here's a good example of what to do. Here's a bad example of what to do. So that can be helpful. And this is kind of what I hinted at earlier, right? There's always this notion of providing both good and bad, what to do, what not to do. And then the other part is, the ordering may or may not matter. I think it's a little bit of an open question. I think it ordered matter with smaller, older models. As models have gotten bigger, more powerful, I think it matters a little bit less. But you should do some experimentation and trial and error, and kind of understand the impact. Some of these research papers will actually try different methods of setting an order, inverting the order, choosing a random order, and then kind of understanding what's the performance impact. Meta prompting is one that I find a little bit more interesting, and I'm surprised maybe that I don't see it quite as much as I would expect it to. When we think about few shot, approaches, that's essentially this top image here, where you usually have an example, a very concrete example with actual values. In terms of meta prompting, the idea is to kind of, replace that with a slightly higher abstraction, right? We want to provide the model with a structured solution, right? Here are the logical steps to solve this problem, rather than necessarily just giving you a few examples, right? And I think the idea here is that when you provide concrete examples, the model is not able to generalize to a broader range of tasks, right? If you have problems that deviate, too far from that concrete example, you might find that the model is coming up short. So in some sense, it's probably a closer approximation to zero shot because you're not actually giving it concrete examples, but you are giving it a very structured, logical approach to solving the problem, which hopefully it can apply to a broader variety of problems. So very much relies on logic as opposed to concrete, steps and values. And here's another example that might also be kind of helpful. As you can see in the top, we have this quadratic equation and actually put in values, right? So it kind of specifies, here's some examples, here's how we're going to perform this calculation, versus in the second one, which is the meta prompt, we're not actually specifying the outputs, right, or results. We're just saying, here's the calculations you need to perform. We're not going to tell you the results of those calculations. Chain of thought, probably in addition to few shot is probably the most popular. And of course, chain of thought kind of incorporates few shot almost all the time I see it. And this is really a case where we're trying to encourage the model to perform more common sense reasoning rather than just trying to state a fact. So we want to use natural language to kind of describe some of these reasoning steps. How do we start to break down this problem? Here's each of these steps that you perform, and kind of inducing it to do this step by step, right? Sometimes you might even see that appended to your prompt. Answer this question in a step by step fashion. And that will give you, a higher likelihood of coming up with the correct solution, right? Or the right answer. But, the other thing that maybe is not as considered as often is how it can help you understand where the model is failing, right? Or struggling. If there's 6 steps to reasoning, it's helpful if you understand that it's struggling on step 2 or step 3. It's not as helpful if you just know that the answer was wrong, right? But you don't know how or why it came to the wrong conclusion. So these are building blocks. We'll look at few shot and chain of thought is building blocks, and we'll see these mentioned in some other techniques here.
Shane, just to add one thing to the chain of
Yeah.
thought, in the demo that we're going to look at later, you'll actually see me um, use chain of thought as a way of figuring out why the prompt that I was developing was giving wrong answers. And even though the end LLM responses I was optimizing for, I didn't want the chain of thought responses. In the process of getting there, I used it just to figure out where the LLM was going wrong, and it was super helpful.
Nice, nice. See, Grace and I were approaching this from 2 different perspectives, and we still met at the same point. Self-consistency. This is very much similar to chain of thought, but the motivation here is that chain of thought relies on greedy decoding, which is really a way of saying that we're allowing the model to pick the most probable response, right, or rationale in terms of coming to it. And the proposition here is that, well, for complex tasks, in particular, there may be multiple ways to solve these, right? Which means there may be a variety of reasoning paths to get there. And so the idea is, well, why don't we prompt a model and ask it for multiple ways, multiple reasoning paths that get to the solution, and then given, say, 3, 4, or 5, we can choose the most consistent one. Now, in the research paper, this is a little more, complex in terms of how they're choosing the consistent response. You can see in the diagram they talked about marginalizing out the reasoning paths. There's some mention of actually looking at the underlying probabilities and confidence levels coming from the model. In more simplistic terms, which I think they use for some of their experiments, you can simply do a majority vote or kind of take the probability, overall of each answer and kind of use those. But the idea behind this is the consistency is going to give us higher confidence. So if we have, 5, reasoning paths and 4 of them come to the same answer, but maybe they use different approaches to it, we're more confident in that answer, right? The more ways to solve it and come to the same conclusion, we assume that is the right way. So this is great for question answers, is great for coding tasks. The second image you'll see on the bottom, I like this one. This came, I think, out of DeepMind. Universal self-consistency. My interpretation, this is simply an easier approach to it. So in this regard, yes, we still ask the LLM for multiple responses, but then instead of trying to implement an algorithm to choose the most consistent answer, simply pass all those responses back to the LLM and ask it to choose the most consistent response. So in this case, we're trying to incorporate sampling here to better understand and kind of get to that right answer. Generated knowledge, I think, is also an interesting one. I think the short of it is there are scenarios where we can simply ask the model to generate its own context, for lack of a better phrase. So you might say that, instead of providing me an answer based on an assumption or based on common sense, use this question to, retrieve a set of facts, then use those facts to answer the question. So it's a little bit of a two-step process, and you could use different models there, right? Maybe we, ask OpenAI, given this question, tell me about 5 relevant facts. You could then go to a smaller model and say, given this question and given these facts, generate an answer, and it's going to do a better job. Active prompt. This one is, again, we're starting to see more variations here that incorporate, chain of thought and few shot. But the question proposed here I thought was fascinating, which is how do we know what are the best examples for few shot? So again, this kind of touches back to the beginning when I said that we want prompts that are a little bit abstract and a little bit more flexible, right? That we can take advantage of generalization a little bit better. And so if you're building an AI assistant and every prompt, is appended with 3, specific examples, it's quite likely that there are going to be a lot of cases where those 3 examples don't help. They're not right there. So really the meaning behind this research was, is there a way that we can identify the best examples that we should be adding? And so they kind of grab a test set, push that test set through an LLM and kind of capture the probabilities or the confidence of those responses. Then the ones which it is least confident in, we can send those back to our subject matters and ask them to create chain of thought examples with rationales and answers. What you do with those kind of varies, but the idea is that you'll build a pool of chain of thought examples that you can use to attach to questions. And while not, explicitly mentioned, or maybe I glossed over it, my take on the application of this is that it would be really great if I could actually build that pool of chain of thought examples. And then when a user submits, a request or a question, I could, for example, use a similarity search. So find me, 3 or 4 examples that are the closest approximation to this particular question. So now every question that comes in, it has examples that are more closely aligned with it. Directional stimulus, again, there's some similarity here in that we're still trying to steer the model towards a specific answer. So that, given a particular context, whether it's a health insurance policy or a news article or, an invoice, and you want maybe a summary of it, or some other type of question, but there's specific things you're looking for in the summary, you can kind of provide hints to the model. And it's really just kind of a list of keywords, if you will, or phrases that are appended to it. And the approach that they took here, which you see in the bottom diagram, is they trained a policy model on a number of these inputs, right? Articles, invoices. And then what came along with those was essentially ground truth, if you will, or feedback provided by SMEs on what they're looking for in terms of those hints. Once that policy model is built, going forward, every time you receive a request to your LLM, you first pass that information to the policy model to get a list of keywords and phrases. We'll call those hints. And then we'll attach those to the context and then send it to the LLM. So this is just a means of fine-tuning responses to focus on what you consider to be the most important, given maybe a potentially broad amount of information. And then self-ask, I think this is the second to last one. So I'll wrap up in just a minute here, make sure I leave time for Grace in the demo. Self-ask is the idea that, and this is a little bit similar to what you heard me describe previously, where we want to get the LLM to, kind of act or require previously unseen knowledge. And the way they think about this in the research paper is unrelated facts. So that's what you see in the underlying question in the upper left. Who was president of the US and superconductivity was discovered? It's exceedingly rare that any of these models were trained on data that specifically said the answer to this question. They were, however, trained on, when presidents, started and ended their terms. They probably have information on when superconductivity was, discovered. So they need to correlate those two distinct facts to come up with a new one. And the basic process is, we write a prompt. We, of course, add some examples there. And then we ask the LM, do you need, to follow up with an additional question? And if it does, it'll say yes. And then it'll propose a question, come up with the answer. And it does this repeatedly until it's acquired enough facts to then give you the answer, which it will. And finally, least to most is an interesting one. A lot of these, it kind of started, a chain of thought, but we're trying to break down, even bigger, even more complex examples by replacing them with a sequence of much smaller subproblems that are easier to do. So generally speaking, this all isn't necessarily in the diagram here on the right, but you might start by providing an example or a couple of examples of how the LLM should decompose, right, big problems into smaller ones. And then once you provide those examples and your specific question, you're essentially asking it, right? Identify the first problem, provide me an answer to that problem, that subproblem. It does. Great. I will append that to the original prompt and then ask you to do it again, with the second subproblem and answer. And so kind of as you do this repeatedly, you acquire the answers to all these subproblems. And then on the final attempt, the LLM should have all the necessary answers to give you the answer to the original bigger problem. That's what's happening here. All right, I'm going to wrap up here, but I did want to say that there's a lot more techniques. I picked 9 to highlight today. There's, I mean, maybe hundreds, I guess, if you were to scour all the research. But we are planning an upcoming webinar in the next couple of months on agentic RAG. And in that one, I think I'm going to introduce a few more that you see here. So if you've heard of things like React or Reflection, I don't have time today to cover them, but when we get to that, I think they'll be more relevant in that space, and we'll try to touch on that. But with that said, I'm going to turn it over to Grace.
So we are talking now about prompt development use cases. And as I mentioned, endless. I don't want to claim that the 4 listed on this screen are the only ones, but some major buckets that I've been thinking about lately. The first being optimizing question answer prompts. And that's the use case that we're going to take a look at today in our demo. One related, maybe sub use case for that that we often see with enterprises is developing chatbots. Specifically, you might want to develop a chatbot that understands your enterprise specific knowledge and can answer customer questions based on your company's policies and information. Evaluation is also a huge use case for prompt development. One example being creating an LLM as a judge using prompt development that then you can use to evaluate. And as Shane mentioned, synthetic data generation. That's one that I'm really passionate about. So hopefully we can talk about it in a future webinar. So how does Snorkel Flow handle prompt development? We designed our prompt development workflows to really empower users, you guys, to be able to create and experiment with and optimize prompts iteratively. So we're going to see a lot of these features in the demo, but just to highlight a couple of them, being able to write and run prompts specifically on your data set, the ability to select from a variety of models so that you can try your prompts on different models and see if maybe one works better than others. Um, you can tune using both system and user prompts. A big one for me is prompt versioning. So you can actually track the progress as you're iterating. And our comparison view that we'll see later, I find really helpful in seeing how that progress is going and being able to compare various prompt versions. Um, as always, very important for enterprises, workspace isolation. Um, and then collecting subject matter expert feedback, something that is we believe at Snorkel so important for really any use case. And so we have integrated our prompt development offerings with Snorkel Flow's annotation suite so that you can very easily collect that feedback and leverage it to improve your prompts. And of course, evaluating your results. So an example use case, this is high level, and then we'll dive into the exact demo we're going to look at today. But optimizing question answer prompts. So in this case, the data scientist might upload a data set that has a series of questions and maybe some context for answering those questions if you want to provide context that is specific to your company, your domain. Then within Snorkel Flow, you can create a prompt development workflow and configure and test different combinations of prompts with multiple LLMs to figure out what combination produces the best results for your use case. So the value is there. Time is incredibly valuable, one of our most valuable assets. So efficiency is so important, being able to rapidly experiment and also optimize the performance of your models. And then scalability. You want to make sure when you are deploying models in production for real world use cases that this is going to be a reproducible and scalable solution that will work for all of your downstream integrations. So for today's demo, we are going to take a look at a collateralized loan obligation data set. If that sounds confusing and overwhelming as a subject to you, me too. And that's actually why I picked it for this demo. We are going to be developing basically a chatbot, but optimizing for question answer pairs. So our input data set will have the question that maybe a customer asks about their collateralized loan. And each data point will also have the context needed from the company in order to correctly answer that question. So what we are trying to do is optimize our prompt to best answer that question based on the specific context provided and make sure that we are providing concise and accurate answers to the customers. So the first thing we're going to do in order to create a new prompt workflow is click on our prompt icon on the left navigation bar in Snorkel Flow. And we are going to create a new prompt. I'm going to call this prompt CLO answers. And I am going to select my dataset loan questions. Before we get started with prompting, let's take a look at the columns in the input dataset. This dataset contains questions about collateralized loan obligations. It also has the context needed to answer the question and golden answers that subject matter experts have provided. This golden answer is helpful to us because we are going to use it to evaluate the quality of our LLM response as we continue to refine our prompt. The first thing that we're going to do now that we've created our prompt workflow is select a model. In Snorkel Flow, you can use any of the models that you have set up using your FM management. For this demo, I'm going to use OpenAI's GPT-4o model. Next, I am going to specify my prompt. Snorkel Flow allows you to specify both a system and user prompt, or just one or the other. To start, I'm going to just provide a simple system prompt telling the model that it is an expert on collateralized loan obligations and to keep its answers concise. I'm also going to tell it to answer the questions provided in the questions column Now I'm going to run the prompt and we'll take a look at the LLM response. Okay, now that the LLM has run, let's compare the responses with the golden answers. Taking a look at the LLM response for our first question, based on this prompt, it did answer the question correctly. Let's take a look at the next one, though. Here, we are asking it to answer when the ramp-up period ends. Based on the golden answer, we know that the correct response is that the ramp-up period ends on the effective date and that the effective date is earlier than September 15th, 2019. Here, the LLM says that it cannot answer the question based on the given information. But in fact, we know that the context does have the information required for the LLM to answer. So let's try a different prompt to see if we can get a better response for this question. I'm going to edit my user prompt to be a little bit more specific. I'm telling it that its task is to answer the question based on the provided financial document, and I'm telling it exactly which columns have the financial document and the question at hand. I'm also going to get rid of this collateralized loan obligation reference in the system prompt and just say, provide accurate and concise answers. All right, let's run the prompt again and see what happens. Once again, the LLM is responding incorrectly to this prompt. It still doesn't believe that the financial document explicitly states when the ramp-up period ends. Okay, let's try something a little bit different. I want to understand why the LLM is reaching this incorrect answer. So I'm going to provide a much more detailed system prompt. I'm telling it it's an expert on the subject, and I'm saying, given the context information and no prior knowledge, think step by step and answer the query. I'm also providing it information like when answering a question that requires a date, like this question does, make sure to include a day, a month, and a year. And I'm letting it know that the ramp-up period is a synonym for effective date. I'm also giving it some examples of how to answer. Since I already provided the task in the system prompt, I'm going to remove that from the user prompt, and we will run it again. Okay, this prompt seems to have solved our problem in terms of the ramp-up period question. It is identifying that the ramp-up period is the same as the effective date, and that the effective date occurs on September 15th, 2019. Let's check its responses for the other questions. This LLM response is correct. It is going into a little bit too much detail and explanation of thought process for the use case that I want, which is a chatbot for this financial institution that provides users with a very concise answer. However, it's providing all of this rationale because I asked it to think through the problem step by step and to explain its logic. We'll take a look at one more question. Same thing. It's answering correctly, but it's walking through a little bit too much step by step. So let's see if we can simplify the prompt to still provide the correct answers, but not give us so much step-by-step thought process. In this version of the prompt, I've returned to our earlier system prompt, just telling the LLM to respond accurately and concisely. I've moved the task to the user prompt, telling it to answering the following question based on the provided financial document. I've also simplified the requirements just to mention how to answer questions related to dates and providing that ramp up synonym. I've removed the requirement to think step by step and provide that in the answer because, in fact, we don't want to see that in our final LLM response. So let's try running this version. All right, this version looks like, at least for this question, we're getting our golden answers. This question asks, when is the first starting payment date on this deal? And our LLM response is exactly matching our golden answer. Let's check out some of the other questions. Again, matches exactly the golden answer. I'm feeling like this is the best version of the prompt. Once again, exact match. Let's check the fourth. For the fourth question, the LLM response includes all of the components of the golden answer, and it actually broke it down into bullet points, which I think makes it easier for a customer to read through. So I feel like this is the best version of our prompt, but let's move over to comparison view so that we can actually confirm that. So if you click this icon in the upper right corner, we move to comparison view. In this view, you can compare any two versions of your prompt. Right now, we're comparing version 4, which I think is the best version. And let's compare it to version 1 for now. And we'll move back to the first question. Here, we're aiming for the golden answer. Simple sentence, the latest that this deal can go into effect is March 20, 2019. In our most recent version of our prompt, we get that exact answer. In version 1, we got close to that answer, but not as simple as it could have been. In version 2, we did get the right answer. In version 3, it over-explained a little bit. Comparing question 2, in our most recent prompt version, we got exactly the golden answer we were aiming for. In the first version of our prompt for this question, the LLM said that it couldn't answer based on the information given. We knew that was incorrect. Version 2, same problem. And in version 3, we did get an answer, but it wasn't quite the golden answer we were going for. I love comparison view because as I'm developing a prompt to really optimize for my desired output, I try a lot of different versions, and it can be hard to remember which one produced the best outputs. Comparison view makes it really easy to look back at the previous prompt versions you've tried and assess which one you like best. Here, it's pretty clear we like version 4 best, so I'm actually going to star it as my favorite, and I might even change the name. I'm going to call it best version. And I might want to remember that version 3 was a little bit too verbose. And that version 2 provided incorrect answers, as did version 1. This is where we'll end our demo today. But if I was continuing on to develop this prompt to be deployed in an enterprise setting, the next step that I would likely take is to send this data over to be annotated by my subject matter experts. I can do that directly from the prompt page by creating a new annotation batch using the button in the top right corner next to our settings icon. This makes it very easy to request subject matter expert feedback directly from the prompt page. And once your subject matter experts have provided that feedback and committed it as ground truth, you'll actually be able to see it on the prompt page in the right-hand panel. Again, we'll save this functionality for our next demo.
All right, wonderful. I think the timing is pretty great because we're at about 5 minutes left here. So I think we'd be happy to, kind of ask any questions that might have come up. There was one in particular here. Could meta prompts be used to create good examples outcomes? So for example, writing a blog on something, and then create a few shot prompt, which uses those examples to scale farther. I think you could. I think it's a fascinating approach where I can see, kind of the solution being, here are the steps, to create a well-written, blog. Start with an introduction and then make your case and, add a catchy conclusion, right? I'm making this up. And then maybe provide, as context, some degree of information from which to use to write the blog. And then, yes, you could use that in few shot. I think my only hesitation might be just the token count, as you start generating, lengthy blogs and then, potentially using multiple of those as context. You're probably going to start chewing up tokens there. But yes, I mean, theoretically you could. I think it's really interesting though. When I saw your question, my second thought was I could probably use prompting to extract those steps if I had a really good blog, right? It would be interesting to pass, a well-written blog to, state-of-the-art model and then ask it, based on this being a perfect example, what are the steps that you would recommend another author take to write a blog that is just as good as this one? And then maybe those could actually be used as part of your meta prompt. So definitely, interesting question. To the follow-up question, which I thought was really great, can you mix multiple models for prompting? You can, and there are some examples where that's done in the experiments. I think it might have been the knowledge generation one, where they actually solicited from a very large model core knowledge and then pass that knowledge in the question to a smaller model, right? Because it wasn't important that the smaller model already have that knowledge. It just needed at least basic reasoning capabilities to apply it. So you can. Conversely, I would say that you can also mix and match these techniques. So definitely some of the most advanced approaches are bringing together, either these techniques as is or some of the principles, of these techniques. Another one, how does chain of thought differ from follow-up questions asking the LM to improve the prompt output? I think the way I would answer that is Chain of thought is single hop, right? So it's generally a single request. Here's my, rationale. Here's some examples. Please provide an answer to this question with your own rationale. Some of the other techniques move into a multi-hop direction, where instead of asking the LLM to do it all at once, they will actually, prompt the LLM multiple times, right? It could be once for each subproblem, once for each, follow-up question. It could be, as you saw in self-consistency, maybe I just want to prompt the same model 3 times, because of the right temperature and top P, I might get a broad variety of answers and rationales. So I'd say that's kind of the big difference between chain of thought and some of these other techniques is they're moving to more of a multi-hop, which, yes, that means additional compute, and probably latency too, for that matter, but it can result in much higher accuracy or correctness as well.
Hey Shane, I'm seeing a great question in the webinar chat that I'd like to address.
Mhm.
The question is asking me how I decide where to stop when iterating on a prompt, how many examples are enough, and how I decide when to send the results to a subject matter expert. Um, I think that's a great question. It depends on the use case. I've definitely had use cases where I have maybe 50 or even 100 versions of my prompt. Um, Deciding where to stop is either once I've reached a point where the LLM responses are good enough and I feel confident about that, or when I need subject matter expert feedback to tell me whether or not these responses are good enough. In the demo we saw, I already had golden responses that the subject matter experts had provided um, when the day before the data set was uploaded. But in cases where you maybe don't already have that ground truth, this is the response we're aiming for from the subject matter expert. In that case, I might do some initial iteration and then send it over for feedback once it's reached what I think is a decent spot, to see if the subject matter experts agree.
Good one. Good one. Let's see. I'm just kind of scrolling through. There was an interesting one here, Grace, which is actually very true. Is the fact that LLMs come out with new versions. They're bigger, they're more powerful, they have greater reasoning, and then that can have an impact on your original prompt. And so I think, my follow on to that would be yes, it's absolutely true that if you're going to change your models, certainly you might have to modify your prompts. I don't know if you have anything you wanted to add to that.
Yeah, I think that that happens frequently. And that's part of why I love the ability in the prompt dev to use different models. I also think with our collaboration with the evaluation functionality in Snorkel Flow, that can be a great way to get um, quantitative information on, hey, I changed my model. Is this causing regressions in the quality of the responses that are being provided? Or is in fact this on par or better with the responses from a previous model? It can be very hard as new models come out, or even sometimes as LLM providers tweak a specific model that you are already using, and you may or may not be aware that that change had been made. So even within a single model, sometimes you do see regressions that can impact your responses.
Nice. So I know we've ran a couple minutes over here, and I realize that we still have a fair amount of questions that we haven't answered. So I just want to let everyone know that we'll reach out to you offline, to try to get these questions answered and connected. I know that some of you have asked about the presentation. So that will certainly be a follow-up. Someone will connect with you offline, and I'll try to make sure that they know who's asked for the presentation. But if you want it, just reply to them, let them know that you're looking for, a copy of the presentation, and they'll be happy to get that for you. And then finally, when we do end here in just a moment, I believe there's a short survey. Always appreciate it if you can fill that out. It's super simple questions, right? Would you recommend this webinar? Was it informative? Any other feedback? So by all means, feel free to use that feedback to tell us if we did something great. That's always nice to see, but please feel free to be frank and blunt and tell us if there's something that we didn't do, that well, that we could have done better. And also anything you might like to see in the future. Like I said, at top of mind, I want to do something on agentic RAG pretty soon. But if there are other topics that are interesting to you that you'd like to see in a webinar, or that you'd like to talk, a little bit more detail with someone here, please, feel free to use the survey to let us know. But with that said, appreciate, some of the comments you guys have already shared in the chat. I try to keep an eye on them. I see them. Thank you. Hopefully you learned a little bit and this was worth your time, and we'll see you hopefully next month for the next webinar. Thanks, Grace.
Thank you, Shane, and thank you everyone for attending and your thoughtful questions.
Bye, everyone.